Okay, welcome to our wonderful webinars. We're so blessed to have Milene here, especially as it's a national holiday in Brazil. So she's taking time out of a holiday season to be here with us. So thank you very much. Today, Milene's going to be talking about how to prioritize non-revenue water and the actions that we need to do that. And the great thing about Milene is she's been in this industry for 25 plus years. She's got a wealth of experience working in schools and schools of different countries. So this is going to be an absolute classic. So Milene, we're going to pass this time over to you. If you have any questions for the delegates that are listening to this, please put them in the chat and we'll do the questions after Milene's presentation. But please use the chat to put your questions in. Milene, over to you.
Thank you, Michael. Always nice to be here with you guys. Okay, let's start talking about understanding water loss priorities here. So what is a priority setting? Can you see my screen? Is it working? Yeah.
Yes.
So what is
Yes,
priority setting? It's really important to understand and identify key aspects here. So identify the most important actions to take and determining the sequence of implementation. This approach ensures that the resources are correctly allocated to address the most critical water loss issues first. So effective prioritization requires understanding of both real losses, the physical leakage, and apparent losses like metering inaccuracies, unauthorized consumption, in order to develop the target strategies for maximize the impact in the system. So first of all, I always say that it's really important to understand your system. You need to know where is your water going to. I always say that it's not really technical, but I need to know where each drop of water is in my system. So I have little boxes and all the water that I put into my system needs to be understood. So I'm supplying this amount of water. The consumption is this amount of water. Where is the all other drops of water going in my system? So we have apparent losses, real losses, and each one needs to be understood, and you need to check your system and see if you know where your water is going to. Otherwise, you won't be able to control, you won't be able to reduce the water losses. It used to have a phrase here in some presentations saying, you can control what you don't measure. So it's really important. You need to understand where is your water going into your system. Is it being used? Is it being lost in leaks or in unauthorized consumption? What's happening there? So first of all, we always need to understand that the system need to be measured, and we need to have the water balance for our system in order to start thinking on controlling this. Another really important thing is, let me just, okay, understand that the water in your system, the water losses in your system will naturally increase over time if they are left unaddressed or you are not taking care properly. So you need to understand that the water losses will grow over time in your system. The influencing factors should be pipe age, not like I'm quoting this, but not limiting to this, okay? Piping age, material quality, water pressure, environmental conditions. So it's really important to understand that, okay, I need to address my water losses and I need to combat my losses in the system. And if I'm not doing that, it will be bigger and bigger each year. I always say that's okay, I don't wanna work with that here, and I'm not working with my water losses. I'm just gonna think next year. Okay, it's your decision. But next year, you will have bigger problems, bigger water losses in your system. Okay? So we need to establish our goals. What are our broad objectives here? It's important to say that I'm gonna say something, I'm gonna quote someone's, but I'll mention these goals, but that doesn't mean that they should follow this order. And we need to understand you need to understand what are the main goals for your systems. It may be that not all of them fit your goals. So you just have to understand and see what I'm looking for, what I need to address in my system. So first, we can think about meet regulatory requirements. Compliance with local, regional, national water conservation standards that may cover multiple operational objectives. Reduce operating costs. Oh, okay, I need to decrease expenses related to water pumping, treatment, leakage control, as well as capital costs associated with infrastructure. So it can be also your goal or one of your goals. Increase build consumption. So I can enhance the revenue potential by ensuring more water usage, by ensuring that more water usage is correctly measured and billed to customers. Another goal can be decrease search water abstraction. Reduce the environmental. This is a word that I will always struggle to say, like environmental impact by minimizing the amount of water drawn for natural sources, or even improve service quality, like enhance customer satisfaction through better water pressure and increased hours of service availability. Then we need to understand the criteria that I'm looking for. So I have specific criteria for my plan, for my goals. So we need to understand the difference between effectiveness and efficiency. So effectiveness is the volume of water loss reduction that can be achieved per year or per month or whatever. And the efficiency is the amount of water, the volume of water reduction per money expend, per dollar expend, per pound, whatever. But not always the most effectiveness is the most efficiency. We will talk about this a little bit later. So these criteria often involves trade-offs that must be carefully evaluated to optimize resource allocation and maximize impact on water loss reduction. We can think on an example for meter replacement. So the trade-off here of effectiveness and efficiency. Thinking on residential meter replacement example. We can replace all old residential meters that can be very highly effective because most consumption comes from residential users. Most of the time, the biggest amount of consumption comes from residential users. So we will increase the billable water. However, the efficiency may be relatively really low because the increase in water billing per dollar won't be that great. In the other hand, if you think on changing the large customer meters, replace the old large customer meters may be less effective in terms of total water billing increase. However, it may be more efficient as the cost-benefit ratio could be more favorable due to higher consumption rates and tariffs for these customers. Another example is thinking on infrastructure replacement. We can replace all water mains or service connection. It would be highly effective, but quite inefficient from a cost perspective, from the view of the cost perspective. If you target just the old poor old pipes in poor conditions, with high break rates, it would be less effective in total volume, but significantly more efficient in terms of cost per unit of water saved. Thinking on the dynamic for the water loss control, we need to start analyzing the current losses. So we need to assess the volume of real and apparent losses in order to establish baseline metrics and identify potential problems. You go and work with an action plan. So you can create targeted interventions based on efficiency and effectiveness criteria to address the losses issues. Then you think on implementing the measures, plan the interventions following the prioritization framework to maximize the impact. You need to monitor the results, track the performance indicators to measure the results of implemented measures. And adjust the strategy. So you always need to update your work plan considering the new conditions of the system. So it will always be a cycle. You analyze what you have, you work on an action plan, then you implement your strategies, you check for your results, and you adjust the strategy again and again and again. So this efficiency and effectiveness of various actions will change over time due to changes in volume of real and apparent losses and because of diminishing returns per dollar spent. Close monitoring and analyzing allows for plan updates that correctly balance efficiency and effectiveness. So now let's start working on preparing a comprehensive plan for your system, for each systems. First of all, you need to define clear objectives. Here, we need to establish specific targets, such as achieving a reduction of volume per year with the reduction for selected budget or maintaining efficiency above a certain threshold. So you need to define what are you expecting on your system, on your plan. Then create action inventory. You need to prepare like a comprehensive list of potential actions with estimates of water loss reduction, costs, and efficiency for each intervention. It's important to understand that it's not like a cake recipe. You need to address for each system. You have different costs, different savings for each action. So you need to understand how your system works. Then prioritize by efficiency. You can assemble the plan by adding actions one by one, starting with the most efficient, then second most efficient, and so on until the target is achieved. And then, implement and monitor your plan. You must execute the plan while tracking the performance to ensure that the goals are being met and make adjustments if necessary. Here we have like an example, but, oh, no, not this, yes. So sample plan objectives, which can be our objectives here, maximize the efficiency to achieve the reductions of some amount of water with the most efficient mix of actions, considering least cost and highest efficiency. Work within a budget, so maximize the reduction for the selected expense. It's really important to understand here that sometimes we do have a plan, we do know what to do, and we understand that if I change all the old pipes and use pressure control for the whole system, it to work properly, but sometimes we don't have the budgets. So we have to put all the numbers in the plan and understand what will work better for your system here. Oh, I can't read here. Maintain the minimum efficiency. So maximize the reduction of efficiency greater than the amount that could be effective value of water supply. So we need to keep adding actions one by one until the efficiency of the actions reach down to the target minimum efficiency. This is an example, and I need to thank Alan here that worked with us with this project that I'm using here as an example. We always think on implement the low cost, high benefit activities first, and then complementary activities, and then high cost and high benefit activities. And you have like short-term actions, mid-term actions, and long-term activities for each losses in your system. Either real losses or apparent losses. So most of the time when you're thinking about real losses, okay, the short term will be always leak detection and pressure management, but sometimes you need, like in the system, to work in the system, to get in the phase to work with pressure control or work with DMAs. So you have short-term actions that should be easy for you in your system for one and not for other people. Like, okay, I already have DMAs, so I can work on pressure management here, or no, I don't have DMAs, so I'm gonna start with, okay, short-term action will be leak detection, and then I have like the complementary activities for work on medium terms and long terms. It's not always the same. Like pressure control can be the first thing to do, but sometimes you don't get the maps for the system, so you don't know how to work on that. So you have to prepare everything to start working. This is an example for a real loss action plan. Like start implementing the low cost, high benefit activities and then complementary activities, so I can work on the high cost and high benefit activities. You can look like this example for the last one. I'm sorry, my screen is not working here. The prioritization of real losses should follow a cost-benefit classification, as this one in the example. It shouldn't be the same for every system. These frameworks can help the utility to identify which interventions will provide the greatest return for the investments. The activities can be analyzed based on the implementation costs and potential benefits, allowing the utilities to focus first on the high benefit, low cost interventions before moving to more expensive solutions. This approach ensures efficient use of limited resources while maximizing water loss resources. So when we think about real loss intervention strategies, we always think about active leakage detection, surveys. Sorry, my screen keeps. Surveys using acoustic equipment and other technologies to identify hidden leaks before they become visible. Rapid repair response, create protocols to quick repairs of the leaks to minimize water loss duration and volume. Pressure management, install pressure reducing valves and zoning systems to optimize systems pressure and reduce stress in the pipes. Infrastructure renewal, replace aging pipes and assets based on conditions assessment and failure history analysis. This is really important. Always have the historical data for your system so you can understand and choose wherever you are working at. Considering the apparent losses, we are going to work the same way as real losses. So we will have like the short-term actions, the planning activities, and then the advanced technologies. Again, your system can be ready for the telemetry and AMR, MMI, but not all systems will be in this point. So it really depends where you are and where your system is. Another example, similar to real losses, the prioritizations for the apparent losses should follow these cost-benefit classifications. This framework can guide the utilities selecting on the most efficient interventions. The classification helps identifying which meter replacement programs, anti-fraud measures, and technological implementations will provide the best returns, allowing for strategic allocation of resources to maximize the revenue recovery. So sometimes here I'm talking about, if you see this example, high cost, high benefit AMI deployment for large customers. Oh no, I do have all the systems now here, so it won't be high cost for me. Okay, I just change it and put in the low cost, high benefit. But it's important to understand that each system must have this kind of structured cost benefit classification, okay? Considering apparent losses interventions like meter replacement, replacing aging or inaccurate meters, prioritizing large customers and non-problematic meter types to improve measurements accuracy and revenue, anti-fraud campaigns, comprehensive program to detect and prevent unauthorized consumption, including meter tampering detection, or consumption pattern analysis, public awareness initiative. Not always you have to work in the field, work with your assets. Sometimes you just need to work with the public, with your customers. And data management, improve your information systems and billing process to reduce errors and ensure all consumption is properly accounted and billed. When you think about telemetry and thinking about advanced metering technologies, these metering technologies represent a great opportunity for apparent apparent loss reduction, but this implementation requires important consideration about the challenges in selecting the best solution, the costs that are always changing, and the detailed studies that are needed to evaluate the best technology for each context. So, as said in the beginning, we really need to understand what are my real losses and my apparent losses in order to work with them and get the best results for each one. So for the real losses, like the physical water leakage from pipes, joints, and fittings, we always think about leak detection, pressure management, and assess replacement. And the impact is either is in the environmental and operational costs. And we always measure with volume-based metrics most of the time. We do have other indicators. I also always recommend that we are working, the group is working with the indicators. Alan White is here with us, and we'll probably have great webinars about this. And apparent losses are the non-physical losses from metering inaccuracies and unauthorized usage. And the impact is on the retail values the revenue loss at the retail value of water and measured with revenue-based metrics. So framework, so we can have this decision-making, assess the current performance, have a water balance. Here you have to work with the water balance to quantify real and apparent losses and establish a baseline performance indicators. Set clear objectives, define specific targets for water loss reduction based on regulatory requirements, financial consideration, or environmental goals. Then identify potential actions. You must create a comprehensive list of possible interventions for both real and apparent losses with costs and benefits. Then prioritize your interventions. You can rank your actions based on efficiency and effectiveness criteria, considering available budget and resources. And then you need to implement and monitor your plan. So you execute the prioritized actions while tracking performance and adjusting the strategy. So for the performance monitoring and adapting, we can think about a continuous improvement cycle. Water loss management requires ongoing monitoring and adaptation to maintain optimal performance, regular assessment of water loss volumes, tracking of key performance indicators, adjustments of priorities, and integration of new technologies and methodologies. So last but not least, as key takeaways for this, we can think on always balance the effectiveness and efficiency. So finding the optimal balance between the water saved and cost per unit of water saved. Differentiate loss types, understanding real and apparent losses to set your goals. Prioritize by cost benefit. Have a prioritization that ranks the interventions, and adapt continuously, like recognizing that water loss control is a dynamic process, and it's not something that, we already have it and it's done, and we are going to follow this year by year. So I think that is it. Thank you, Michael. I'm not sure if
Thank you, Milene.
Any questions or?
We have a couple of questions, and I'm sure there'll be more questions to go in there. So please do put your questions in there. Really great for that presentation. I really liked the kind of efficiency and effectiveness. I love the little diagram that you had that talked about AMI meters. I spoke to a water utility company in Europe fairly recently in the last few weeks, and they were doing really well. They put on lots and lots of AMI meters on their customers, on their commercial customers. And I said, you're doing a great job. And he says, no, the problem is, Michael, we put them on all the small customers because they're the easy ones, the small commercials. He says, we're not getting much benefit from it. We've not put them on the larger ones because they cost more money. So the efficiency and effectiveness on that graph, we see that in real life. So thank you for sharing that. We've got a couple of questions. I think the first question is, where, from your experience, do we see the lowest NRW? What systems or anywhere in the world that you know, Milene, where we see quite low NRW?
Yeah, actually, we can think about that, but it really depends. I will never talk about percentages, guys. I'm not sure if you are asking about this, but if I talk about percentages, Alan White should shoot me in the head. He's balancing. And we got the system that I've worked in and not really heard of, or someone just wrote this number. we got until, I think, 70 or 80 liters per connection per day, something around that. But it's a really low number here. Not here. I've been working in many countries now, but I really think that it depends on your measuring system. If you have like water roof tanks, because we know that it implies of a lot of under registration for our meters, so our apparent losses are really high when you have rooftop tanks. And the age of the assets for the system and the pressure control. So really great areas with great pressure control and monitoring all the flows so you can get to the leaks faster, and no roof tanks, water roof tanks. It should be, in my experience, around 70 or 80. I found these numbers. Oh, but I've heard of 30. Okay, I've heard of, but I've never seen or checked. Or sometimes I work in places that people say, oh, my water losses are around 10%. Okay, now I don't want to talk about percentage, but 10%, and you don't even measure your inlet, your input water volume or whatever. So some numbers should be always verified. I'm not saying that they are not true, but these are numbers that I'm not sure of. So 70 to 80 is a number that I can say, okay, I've worked on that and I've checked those numbers and it's working properly.
Okay, thank you, Milene. And Alan White has put in the chat, he's talked about countries that have quite a low NRW. He's mentioned Denmark and Japan and the Netherlands. And again, it's really useful just for context, because obviously there are different circumstances. So water is quite expensive in Denmark, so they can put the investment in. The Netherlands have some very good hydraulics in the sense that it's a very flat country and it's very sandy soil. So all these things have to be done in context, don't they? On there, we've got a question from Justin on there, and this is what Justin says: do you validate your water balance by using a bottom-up water balance? If bottom-up water balance is not possible, are there any other alternatives to validation?
Yeah, you can work on component analysis for your real losses, because I do understand that when you work with your water balances, all the errors from the beginning will be in the result for the real losses. So the physical losses can be higher or lower, considering all the errors that you have in your other numbers. But then you can work on component analysis, like splitting all these real losses in. I do have a picture here. I can find it if they want, but if you want, but like unreported, reported, and the English word, reported, unreported, and sorry, someone help me here. And background leakage.
Okay.
So most of the time you can have like, you can perform tests in the field. So you can calculate your ICF. So you can calculate your background leaks, and you have the history for all the reported bursts, and you have the ILI for the system. So you manage to kind of check this number. If you are not able to have the bottom up, you can always work with component analysis. Sometimes we've been working for a few years now, and Alan and I sometimes get, oh, it's not this number. Yeah, it shouldn't be this number. So I have all these leaks here, and they are saying that we just have this amount of physical losses, so this is not. So sometimes we go back to the water balance and try to estimate and see where the errors are. But if you don't have the means or the measurements to have the bottom up, you can always work with the component analysis for the real losses.
Okay, brilliant. Thank you. Kelvin. So Kelvin's staying up late because I think, where are you, Kelvin? You're Malaysia, aren't you? He says, please elaborate more on the data management as one of the apparent loss intervention strategies.
Again, elaborate more
Yeah. So
on
how
data
do you use data
management.
management as one of your apparent loss intervention strategies?
Yeah, Calvin, sometimes we have some systems here that we don't have a great system to account all the measurements or all the billing system. Most big companies or companies that are working from a long time, they do have data systems that are really great. So most of the time I always say, okay, apparent losses are like under reading in the meters and the frauds. But data management is apparent losses either, but most of the time in the systems that are working from a long time in water losses, this is not a problem. I think Alan is asking for something. Alan, you can unmute yourself.
Well, I was just going to say that in my experience, there's a lot of places where the customer database is out of date, and or sometimes there's, you know, fraud, so to speak, in customer inclusion or not. And so that aspect of data management is pretty important if you have like old customer database or problems with the database. So
and sometimes we do have, like in the system, this whole area, this whole DMA, this whole sector that is being accounted on the other sector. So you have like this area with a huge amount of water losses and this one with, oh, not losses at all. So sometimes you just have to put everything together and say, oh, okay, this DMA, the water that is coming from this DMA is supplying these customers. Sometimes this is like a huge mess. So you can't really measure and understand where are your losses here.
Okay, brilliant. So we have another question that's talking about what utilities do we think have real low losses. Now, I guess really what I would say to this question on there was there is some data out there. So the leak suite that Alan Lambert looks after has got some data there. Alan Wyatt, you did a paper on it now, probably 7-8 years ago with Roland Lindbergh. So I would suggest that that's probably, if you're looking for utilities specifically or areas, that's probably the best place to go. Jolly, I'm sorry if I pronounced your name wrong on there, but it's probably worth having a good search. But there are a couple of papers written over the last 10 years that are probably quite useful. And what I'll do, I'll put a link to the leak suites in the chat in a couple of minutes time on there. Okay, Alan, you've made some more comments about top down, bottom up. Go on.
Yeah, I just wanted to say that as quite a few of you know, there is a IWA global water loss KPI initiative, and we have a team of people collecting data from the entire world. We have data at this point in 50 different countries. It's not all packaged up and ready to distribute, but if you're interested in the topic and obtaining such data at some point, well, I would encourage you to get involved and help assemble that data so that all of us can have it, you know, down the line. And I put in the chat an email address, waterlossdata@gmail.com, wherein you can ask a question or volunteer to help on this question of data and where are things good or bad, so to speak. Thank you.
Okay, brilliant. And I've just put a message or a link to Leak Suite, which Alan Lambert looks after. That takes you to the countries ILIs, and you can also go back a few pages and find some other information out on there. Milene, you talked right at the start of your presentation, or quite early on in your presentation, about a plan. That's the first thing you've got to kind of do. You've got to put a plan together. From your experience, what can go wrong with the plan? What are common mistakes that people make when they're trying to put their plan together?
You know what? Sometimes people say, oh, we don't have the equipment, we don't have the technology. But I always say the first thing is everybody in the same page, all the people in the same page. Like everybody must understand the problem and the issue of water losses. When I'm talking to people, I always start saying, oh, who here works with water losses? And like 3 or 4, me. And I say, oh, completely wrong. Everybody is responsible for water losses in the system. Everybody must think on water losses in the system. So first of all the people must be included and must be talking about the strategy and the plan, not just, oh, someone just give the plan and give to people to undertake and choose to implement it. So it's really important that everybody is together. Sometimes I go in some places and people say, oh, these are the people that works in the field and we are talking to them. And I say, please, I need to talk also with the commercial people, also with the management people, also with the regulators in the area. Everybody must be thinking together on that. And second of all, thinking on, oh, we do have this huge amount of technologies, but sometimes I'm not ready for that. Oh, we have like this huge solution that it's like magical, but am I ready to work on that? Sometimes I'm in the beginning and I just need to look at my pipes and look at my pressure and start working on the basics. I always say I'm just sometimes using Ferraris on dirty roads, and it can happen. Sometimes we need to establish the first steps first, like it's logical, but it not always happens. You need to understand your system and understand where you are, and then check what can be done here. Sometimes it's important to understand that I need to maintain, is that correct? This must work even after these people, these medical people that are providing like medical solutions goes out of my system. Sometimes, is it feasible? Is it important? Is okay, always important to reduce water losses, but this technology or this solution is suitable for my system. So I need to understand where we are and what can be done with my people and with my employees for the I don't know if this is the correct word, but if it's not possible, is it possible to bring other people to help me out and then help me out and teach me how to use this later? And oh, but I don't have money. Okay, can we think about like performance-based contracts? Sometimes I don't have the money for this implementation, but we do have really ongoing contracts of performance-based formats that are really helping improving the system a lot. So you need to understand what you need. So always first the people, always first who is working with the system, and then what's needed here. Sometimes I just need to start thinking on pressure control like this. Oh, just start controlling your pressures. Just start monitoring your numbers and what's happening in your system. I think that is it. Is it answered?
I think that's fantastic. And Stuart Hamilton, who's obviously he's our chair of the water loss group, and we're glad that he's here with us today. You know, he said that similar thing, hasn't he, Milene? That sometimes people want Ferraris on a dirt road, essentially, or things like that. You know, that sometimes we get obsessed about what's the newest technology, and sometimes we've got to do the basics first on there. Okay, we've got a couple of other questions here, Milene. First of all, and again, we're happy for people to chip in on the chat. When planning find and fix activities, are there any studies that have proven the average leak size on different pipe sizes and different pipe materials?
That had to average leak sizes or different pipe size and pipe materials. Size of zones, I'm not sure if I got it correctly.
I think the question is, do we know when a burst goes pop? Do we know how much water on average it's coming out? I personally think that's virtually an impossible thing to answer because it depends on the pressure.
Yeah.
It depends on the material. It depends on so much on the network and how it's being maintained. I think it's really hard to give a worldwide number.
But we do have, what happens is that I always say that we can't say that one specific burst is leaking this amount of water. But when you think about your system, like the whole burst in your systems, we have a paper, aqua paper, it's like 2001 or it's really old, but we do have these numbers that are really accurate, and we've been working with that for several years. And we also had some field tests that are always confirming the number. It's sometimes 1.6. Okay, I just got 1.54. Okay, this is some kind of calculate for this, for the leakage volume. And you can use this paper. It's aqua. It's called aqua. I can always send if anyone wants, or it's in the Leak Suite library also. But we managed to work on these numbers and get how much water is being lost in the leaks. Not one leak in particular. I always say that if you put all the values in a graph, you have like one big one and another really small, but the whole cloud will be around here. So you can have these numbers in order to calculate how much water is being lost in these leaks for your system. Not one, but you have to consider the material and the pressure. Material because of the N1 equation and the pressure, but not for one specific burst. It's not like, oh, I have this burst. How much is it leaking? It really depends the format of the burst, and if you have just a point or you have like a whole crack for the pipe, something like that. Stuart, would you like to add something?
Yeah, if I can just jump in there. Yeah, I mean, if you look at the there's the equation. It's called the ESPB, equivalent service pipe burst. If you look at that, that's some work that was done in the UK many years ago. I think about 1994, 96 or something like that. If you get in touch with us, we can give you the formula. But basically, that calculates that a normal service pipe burst will leak at 1.6 cubic meters per hour at 50 meters pressure. The formula is calculated, it's a square root formula, so it's calculated out that you can change the pressure all the time in the formula. I've got it on a very simple spreadsheet. Change the pressure within the formula, and each time you change the pressure, the flow rate comes down. Like if you go to 44 meters pressure, it's 1.5 cubic meters. But what you do, you measure your own burst, and we're currently doing this in Ethiopia. You measure your leak, you measure your type of leak that you have with a bucket, whatever, over a period of seconds or whatever you can, multiply that back up and have an estimate of what your leak leaks at. Currently in Africa, we're getting across there. I used to say for Africa, use 800 litres an hour. We're actually finding the leaks we're getting in Ethiopia is about 200, 250 litres per hour at 50 metres pressure. But we're measuring it at like 3 meters pressure, 4 meters pressure, and having to do the calculation to go up. So it can be done. It is easily done. And this is all to do with ESPBs. When you look at a burst main will be possibly 5 ESPBs. a small stop tap leak will be 0.1 of an ESPB. And then you can actually go to a fire hydrant leak could be 2.25. An 8-inch burst main could be 10 times, 10 ESPBs. It's very simple to do. We have the software, we have the presentation, we have it's all available. And if they get in touch with you, Mikel, or you, Milene, we can share that and give it to them, the formula, and also the criteria, what you need. Very simple on a spreadsheet. But reversing it back, when you do a DMA and when you look at the volume of leak, the volume of water you're losing in a DMA or in your system, you divide that back by the volume for your leak, and then you can start to learn how many leaks you have in the system. So forget volume. Volume means nothing to anybody. Start breaking it down into a meaningful KPI, which can say I've got 1,000 cubic meters an hour in that system. Each one of my leaks will at least one cubic meter per hour. I've got 1,000 leaks in that system. Divide the 1,000 leaks by the length of mains. Now you know how many leaks you're looking for per kilometre of main. So it's all what we do. Reinhard did some measurements in California somewhere about 4 or 5 years ago during COVID. Reinhard Sturm did some work with his company during COVID where they measured every single leak they ever repaired or found. So he's got some information as well if you're USA based. I hope that doesn't confuse you too much, but gives you an idea.
Thank you
That's
so
brilliant,
much.
Stuart. So just to say, I put my email on the chat. So if anybody's got any questions or want any more information, please contact me. Milene, one of the first questions we had is, would this presentation be available as a PowerPoint or as a PDF or something?
If anyone wants this presentation, you can email me. I can put my email here and I can send it. No problem.
Brilliant. Thank you on there. Kelvin, it looks like Alan's answered your question. So I'm going to go back to the question above that, which is, based on your experience, Milene, can poor water quality contribute to NRW, non-revenue water?
Non-revenue water, yes. Sometimes you have to have, first thing in my mind is you have a lot of flushing when you have poor quality, and it will increase your non-revenue water. If you have bigger problems with your quality, it can mess with your meters in the system. So I really think it can it can get worse if you have a poor, I'm trying to read it here, quality of water. So first in my mind comes with the flushing and with the meters that can be messed if the water quality is poor. I can think in other things else, but not now.
I think that's a brilliant answer. That's great. Another question we've got is, what's your opinion on replacing pipes using the non-destructive method?
Perfect. Couldn't be better, because most of the time we can't like dig holes in a big city because of the traffic, and it wouldn't be possible to replace a lot of mains if we didn't have these non-destructive methods. These are really very effective, and it's helping a lot to manage our infrastructure right now.
Okay, brilliant. Just to say, for those who do want the presentation, if they could email Milene, please don't just put your email in the chat, because we lose the chat often when this finishes. So it's probably best to email Milene. And again, any other questions, please, about anything else you want to know, you can email me, and I'll put my email there on there. Thank you, Anna, for your views on that, for your information coming through on there about water quality. Very much appreciate that. We did have a question about non-revenue water. Sorry, not non-revenue water, natural rate of
natural
rise.
rate of rise. Yeah.
So
If
this was so yeah. Go on, Milene.
if
How critical is it?
how critical? It's really important because sometimes you are just working and considering your plan with this amount of time, and sometimes next year you won't be able to have all the results that you are expecting if you are not considering the rate of rise for the system. So it's really important in order to understand the problem with the meters, if this rate of rise is really, Alan want to say something, but you need to understand that sometimes you won't have the results for your plan if you are not considering, sometimes no, always. You won't have the results for your plan if you don't consider the rate of rise for the system. Okay, Alan, you can unmute yourself.
Yeah, I fully agree that rate of rise is quite important, but unfortunately, it's not well known how to measure it, and not many measurements are done. And in California, for example, there's an economic model which is highly sensitive to rate of rise, and nobody really has any reasonable information on what the rate of rise is anywhere, you know. Well, I'm exaggerating, a few places maybe, but there's very detailed work in the UK on rate of rise in different types of distribution networks, but this is an area where a lot of work needs to be done. I mean, rate of rise is the key to the survey frequency of leak detection. And so it's a great question and an important topic.
It's probably just worth mentioning. Sorry, go on, Milene.
No, please continue.
I was going to say, as Alan's mentioned, the UK here, you know, we've got water companies or water utilities that if they did no repairs within 3 years, they will double the amount of water they're losing in their pipes. When you look at companies who are reducing leakage by 5 or 10%, you know, in megaliter terms, 90% of the repairs they're doing is just to keep level. You know, they most of the work they do is just to keep the natural rate and rise steady on there.
Yep.
And actually,
Yep.
it doesn't take much more repairs to actually bring it down, which is really interesting. But yeah, it's you know, from the UK point of view, the natural rate of rise is something that we look at. It's so important for us because it's what we have to do just to keep standing still, and it's a lot. It's a lot. It's most of our work is actually just done to stand still, and then a little bit extra to kind of get those reductions on there.
Thank you.
Yeah, Milene and I worked on
I
a
know
project
we are
in Brazil.
heading.
Sorry.
Sorry,
Go
Alan.
ahead.
Please.
No, I was going to say, Milene and I worked on a project in Brazil where we were working on estimating rate of rise from the amount of unreported leaks discovered and the survey frequency and the N1s and all these things. And it's okay, but it needs a fair amount of data to come out with a good result.
Yeah, and I know we are like getting out of time, but I'd like to thank Anna Bochko that always has great inputs about water quality here. She wrote in the chat box for water quality, hard water makes hard deposits start, and with high temperatures, pipes are blocked with a matter of 5 to 8 years. Exactly. Thank you so much for that, Anna. Especially high density polyethylene. I don't know if this is the word in English, very common in Tunisia. And also Bamboo saying something about aggressive water, desalined water causes corrosion in metallic pipes. I think you just got out of time here, isn't it, Michael?
We're coming up to the hour mark. So we just want to thank you, Milene. A couple of other things we just want to say to everyone watching. So we're very lucky to have Milene in Brazil. Now, Brazil, a very important country. We'll remember the 2014 World Cup in Brazil, although I think most Brazilians are trying to forget it. We had the 2016 Olympics in Brazil. And next year, we have something even more important, even better than those two events. We have the Water Loss Conference in Rio de Janeiro on there. So we're looking forward to that. I've just put a link in the chat. If people aren't aware of that, please go on. It's got an absolute great program. Bambos, who is on here, he's on part of the committee who's organizing that on there again. So there's a time to get an abstract in. So if you want to present in Brazil, please go on to that website on there. We've got about 10 days before abstracts finishes, before it closes on there. So thank you again, Milene. We'll let you get back to your national holiday on there, and appreciate everyone who's contributed today. Thanks a lot, and have a good morning, have a good afternoon. Bye-bye.
Thank you.